Hey, Algebra 2, welcome to lesson 115, okay? I had a headache and I started to look at this lesson and it gave me a bigger headache. But not really, it's really not that hard. Okay, it's actually really not that hard at all, okay? Let's look at example 115.1 first before we go into these equations that we're going to be learning today, which look so ugly, right? But they're not as bad as we think they are. Okay, example 115.1 says that 17 equals 10 over to the x plus 2. What is x? And you're like, well, I have no idea. What am I supposed to do with that? Well, remember, we just learned about logarithms. Remember that a logarithm is a way to write a number as 10 to the something. And that a natural log is a way to write e to the something, right? So what happens if we can make this number 10 to the something equal to this 10 to the x plus 2? Then if they have the same bases, we can make the exponents equal to each other, right? Okay, so let me repeat that again because I'm going to show you how to do it. If this is 10 to the something, then we can make the 17 10 to the something and solve by equaling out the exponents like this. Watch. Go to your calculator, hit log 17, and you're going to get 1.23, right? That means that 10 to the 1.23 is 17, right? We know that because look, we can do 10 to the 1.23 is 17. So now we just wrote 17 as a base of 10 with an exponent. So look, these bases are the same, so we don't even care about those. It's 1.23 equals x plus 2. So we minus our x over there, and you're just going to get 1.23 minus 2, negative 0.7. X equals negative 0.7. Okay, I don't know why I keep doing that. 1.23 minus 2, negative 0.77. Okay, so anytime you see this conflict of exponents, you just need to turn this number into a base of 10 with an exponent, or a base of e with an exponent if this is an e, okay? Because now we know we can do that with log and natural log. Well, if you understand that concept, the rest of the lesson is going to be easy. But let's make sure that you understand it. How about you stop the video and do practice A, so we can check it together that you really did understand how to do that concept, so then you're understanding the rest of it. Go ahead and try that. Okay, here we go. X equals negative 3.57. How do we know? We need to write 27 with a base of 10, so it's 10 to the 1.43. We know that because I put in my calculator log 27, okay? So it's 10 to the 1.43 equals 10 to the x plus 5. So now we do 1.43 equals x plus 5. I subtract my 5 and I get negative 3.57, okay? Okay, now let's go into the rest of the lesson. We have these two equations right here. These two equations represent something called exponential growth. Look, if you have bacteria together, bacteria grows very, very quickly. If you have money inside a certain account that compounds interest, the money can grow very, very quickly. That money that has an infinity limit of growing, depending on how much time you leave that money there or the bacteria there, it's going to continually grow. And we call that growth exponential growth. That it has the ability to start down very, very low and go up very, very high quickly. Exponential growth meaning that it's growing on top of its growth. Okay, for instance, with the compound interest, we talked about this before, but if you put, like, let's say $5 into a bank account that's compounding interest, okay, let's say then you get $6 because you had $1 of interest. The next time that you get interest, it's not going to be on the $5, it's now going to be on the $6. So all that interest keeps building up and it grows exponentially, okay? So this is a graph of what exponential growth looks like. And these are the equations of exponential growth, okay? This right here, you can find these in your book. This equation is just the normal equation of exponential growth. This one is for compound interest. So we're going to use both of these today. What this one is this is the amount after a certain amount of time. So this is your answer. This is your original amount, okay, original quantity. That's why the O is there. Times E, remember that's your natural log, to the K times T. K is just a variable. We have to search for that. Either they give it to us or we have to solve for it, okay? And T is your time. Over here, it's the same thing. This is your answer. This is P for principal. That's your original amount of money. E to the R, which is what either they're going to give to us or we're going to solve for, which is your rate of interest, times your time. Okay, so how do we use those? Go over to example 2. In the beginning, there were 400 bacteria in the dish. That's going to be your original amount. 400 bacteria in the dish. We know E is something you put in your calculators, not something that we solve for. The number of bacteria increased exponentially. As soon as you see that it increased exponentially, you know that you use this formula for exponential growth. 3 days later, there were 2,000 bacteria in the dish. Okay, so that is your new amount. Oops. That's your new amount is 2,000. Okay, and your T is going to be 3 days, but they did not give you your K, right? So now here's what we have. 2,000 equals 400 times E to the 3 times K. So our question is, how many bacteria would there be in 8 days? So this is how much bacteria there was in 3 days. How much would there be in 8 days? Well, the very first thing we need to do, guys, is solve for the unknown we already have here, which is K, okay? How are we going to do that? Let's get E by itself. We divide by 400 over here, so we're going to divide by 400 over here, right? Cancel out my 0, so we have 20 divided by 4, which is 5. 5 equals E to the 3K. Well, remember what we did in example 1. If this was a base 10, we could make this be a base of 10 with an exponent and solve it. Well, can't I make 5 with a base of E? Of course I can. Put in your calculator, natural log, right, ln, 5. And you get 1.6. So now, E to the 1.6 is equal to, we'll put 1.61, E to the 3K. So now we just, don't worry about that. It's 1.61 to the equals 3K, so I'm going to divide by 3 over here. And my K is going to equal 0.536, right? Okay. Once I know that my K equals 0.536, what am I going to do? Well, it's asking us now how many bacteria would there be in 8 days? So I'm going to say AT, because that's what I'm looking for. My original was 400. E to the 0.536 times 8, because it's 8 days, okay? There's my original amount times my E with my K and my T. And then I just put it right in my calculator. 400 times shift E, I'm going to do parentheses, 0.536 times 8 close parentheses, like this. Hit enter. 29,128. Okay? Now, is that the exact same in the book, you guys? No, it's not. Is it close? It's 29,000 algal, right? Guys, you have to understand that when you're working with these decimals, one little rounding thing can change everything. And our calculators round in a different way. So up beside that, your book says 29,362 and I got 29,128. It's 29,000 algal. And that's perfectly fine in this situation. I know you want to say, you want to give me like a, you want to pat the anime out, because if anywhere else you got 29,000 algal, I would have counted it wrong, right? But here, honestly, it matters with the decimal. So we can't do anything about it. How my calculator rounds and how the book's calculator rounds is completely different, and that is okay. So we have to accept that answer. Okay? Look at example 3. In the beginning, there were 4.25 ounces of radioactive material. It decayed exponentially. Okay, decayed means that it didn't increase exponentially, it went down like this. Shoo. Okay, but we use the same formula, it's just with negatives, okay? So, it says in the beginning we had 4.25 ounces. That's my A original. It decayed exponentially 10 years later, 3.92 ounces would remain. So we have K, 10K, right, because it's 10 years later. And my result was 3.92, and you can see that it decayed, it got smaller. How much would remain after 30 years? Okay, so let's find our K first. That means we divide over here by 4.25. 3.92 divided by 4.25 equals 0.922 equals e to the 10K. So we have to make this have a base of e. So I'm going to do my shift, natural log, answer. All right, shift, natural log, answer. Oh, no, I'm not. Okay, bye-bye. I'm going to do natural log, answer, because we're trying to figure out what it looks like with the e. And you're going to get a negative 0.08, right? A negative 0.08. So here we go. E to the negative 0.08 equals e to the 10K. So now what do we have left? Negative 0.08 equals 10K. So we divide by 10 over here, which means that K is going to equal a negative 0.008 when we divide by 10, right? Now that is not the answer, so we have to go back and figure out how much would remain after 30 years. So our original is 4.25. We're looking for this one. K is negative 0.008, and we're looking for 30 years. Okay, so in my calculator, 4.25 times, now it's shift natural log with the e, right? Parentheses, negative 0.008 times 30, close parentheses, 3.34. Okay, it would remain after 30 years after it kept going down and down and down. Okay, now let's apply that to compound interest. Look at example 4. Look at example 4. Roger deposited $5,000 in an interest-bearing account that paid 7.5% compounded continuously. As soon as you see compounded continuously, you know you can use this equation. It's just like increase exponentially, okay? So, how much money did he have in 10 years? So, we're looking to find this. He started out with 5,000. E to the rate is 7.5%. That's okay, 7.5% is written like this is a decimal, right? And you move over 2 decimal spots because it's percentage, so it's 0.075 times T, which is 10 years. Okay, and then you literally just put it into your calculator, just like that. 5,000 times shift natural log for the E, parentheses 0.075 times 10, close parentheses, equals $10,585. Okay, and they got 600. So what in the world? Look at that. In 10 years, his $5,000 is going to grow to $10,585 because he found a good account that lets his money grow exponentially at 7.5%. Okay, so go ahead and do letter B and letter C for your practice using your formulas, and we'll come back and check it together. Okay, here we go for letter A. We already did letter A. Put on B. 1,840 because it's 980. E to the 9 years times 7% interest. You just put that in your calculator, you get 1,840. Here, we had to solve for K first, right? We started out with 400. In 3 years, it got to 1,600. So we're going to divide by the 400 and get 4. Write 4 as a base of E, which means it's natural log 4. We get 1.386. 1.386 divided by 3 to solve for K. K is 0.462. So we come over here, 400 original, but now we want to know after 10 years what happens. E to the times 10 times 0.462, and we get 40,597 rabbits. Okay, there you go. If you have any questions, just let me know. Bye.